Okay, welcome back, guys. So today we'll be looking at production. Okay, and we'll be looking at um, the short run and long run. This time we are not using a table. We'll be looking at how we can derive our optimal labor usage and capital from word equation. Okay, and the most popular function that we use when it comes to um, production that is in the form of statement is the Cobb-Douglas function. Okay, we have the Leontief function, we have the linear production function, but the most popular is the Cobb-Douglas function. Okay, so we'll begin with the short run, then we'll look at the long run. So in each case, we'll take a question and dissect it and see how they all work. All right, so let's pick this question. So it says that given the production function of Gold Door Manufacturing Company Limited to be Q equals 3L minus 0.3L square, where price for each product is 10 cedis, additional cost incurred in hiring and extra labor is 6 cedis. Find the optimal labor usage in the short run. So this question, they gave us the short run straightforward that we should find. So that should be easy. All right, so let's first quote the function. So before you begin, you write your function down. So it is Q3L minus 0.3L squared. Okay, so in the situation where they don't give you a clue as to whether this function is in the short run or long run, you know that looking at this L here and L here is only one variable. Okay, that makes this function to be in the short run. And in the long run, there are two different variables. So when we take the long run question, we'll also see how we'll dissect that. All right. So according to the question, price is 10 cedis. Okay. So we are listing everything in there, and the cost of hiring an additional labor. So with this, we call it marginal cost of labor, okay, which is what 6 cedis. It is also wage, okay. So marginal cost of labor or wage, okay. So to be able to solve this, you have to keep this formula in mind. M, so let's begin. So MRP subscript L equals MCL. Now this stands for marginal revenue product of labor equals marginal cost of labor. So what this formula is trying to tell us is that to be able to find our optimum labor usage, okay, it is where the marginal revenue product of labor equals the marginal cost of labor. So already we know our marginal cost of labor, okay. So we have to find our marginal revenue product of labor to be able to ascertain our optimal labor usage. Okay. So now that we've quoted this, we break this MRPL down. So MRPL equals price times marginal product of labor. Okay. So if you break MRPL down, you're going to get P times MPL. Okay. So this is the breakdown of MRPL. And already we have price, which is 10 over here. Okay. So the next thing is we should find the MPL. And to find that, we have to differentiate. So MPL equals, okay. Now we have to differentiate L from this Q function, okay. From this Q function, okay. Which means that MPL equals the Q, sorry, delta Q over what? Delta L. Okay, so if you know differentiation very well, you know that we will be differentiating L from the equation. Okay. So to do that, we differentiate 3L will give us what? 3. Differentiate 0.3 L to the power 2 will give us what? Minus 0.6 L. Okay, so when we differentiate MPL, the Q function, we are getting 3 minus 0.6 L. Okay, so this is our MPL. So we put it back into this equation. Okay, we already know our P, which is 10. So we'll say, let's put implies that um MRPL equals what? Price is 10, right? So 10 multiply by, then we open bracket and we put MPL there, which is 3 minus 0.6 L, brackets close. So we then multiply, so we get 30 minus 6L. So our MRPL equals 30 minus 6L. So now that we've gotten this, we are almost done. So our MRPL, which is marginal revenue product of labor, equals 30 minus what? 6L. So the function says that MRPL equals what? MCL. Okay, to be able to find our optimal labor usage. So we put this function into this. Already MCL has been given to us. So we say 30 minus 6L equals what? 6. Okay, so now that we've gotten this, the work becomes easier. So we want to find L. So we do change of subject. We bring this 30 here. So it becomes negative 6L equals what? 6 minus 30, right? Okay, so it becomes 6L equals, if you subtract positive 6 from negative 30, you are going to get what? Negative 24, right? Okay, so now that we've gotten this, we divide both sides by what? 6. So divide both sides by 6. So 6 cancel itself 1, cancel this one to 1. So we get L standing alone. Now here 6 cancel itself 1 and cancel this one how many times? 4. Okay, so this is negative 6. Okay, canceling negative 24, that gives us what? 4 over 1. And you know any number over 1 is the same number, so L equals 4. So in this case, so you can therefore say, therefore the optimal labor, the optimal labor usage is 4. Okay, or the optimal labor usage is 4 in the short run, and you end it. So that is how you solve a question in the short run. So take a look at it carefully. Okay, always remember this formula. Okay, this very formula when you are solving a question in the short run. Okay, you have to expand this. Okay, so if you expand it, you're going to get this. Okay, now when you get it, when you break it down like this, you make the work easier. So P has already been given. The only thing we have to find is MPL. Okay, and to find MPL, we have to differentiate L from the Q function here. So that's what we did over here. And we had 3 minus 0.6 L. Okay, then we put this back into this formula. Okay, so we say MRPL equals what? 10. 10 has already been given over here. So there's 10 times, you open brackets, you bring this value that we had from differentiation, from differentiating our Q function, which is this. So then you multiply 10 through this to get this, okay? So when you get this, you are done. Then you put this answer back into the formula, okay? So if you put this answer back into the formula, it's going to be what 30 minus 6L equals 6. And then you do change of subject to arrive at your L, which means that your optimal labor usage, okay, is 4. So that's how you solve this question, okay? All right. So this is for production in the short run, okay? So let's pick a question in the long run which mostly appears in your exam and dissect it, okay? All right. See you.